Следующий наш доклад.
Our next speaker is Gael Hernandez.
Running and operating a global DNS Anycast network.
Hi everyone, my name is Gael Hernandez. I work with PCH, Packet Clearinghouse, and I'm the presentation right before the coffee break, so I'll try to be quick. It's a lightning talk, so it's supposed to be short. The slides are available on the ENOG website, and thanks to the program committee for selecting and letting me coming here to tell a bit more about what we do at PCH and how we've built and how we operate this global DNS Anycast network. So just to check a bit with you, please raise your hands if you know what Anycast is. And, okay, very good. Well, that's the right. What about who in their networks is implementing some sort of Anycast technology within their networks? Okay, so some of you are familiar with that is. So as opposed to unicast, where you identify an IP address with a unique destination, or multicast and broadcast, where you identify an IP address with multiple devices. In Anycast, you're also identifying with multiple devices, but by routing, you're able to select only one of those destinations in the end. And I'm going to show you how that works is thanks to BGP, the Border Gateway Protocol, who helps to do this kind of magic. That's why we talk about Anycast as a technology somehow. An Anycast Cloud, and that's what we've built, and we're not the only ones who've built Anycast clouds, or we've used clouds to deliver and distribute content. But what we do is you have a distributed cluster of instances of a server, and they're generally the same type of server with the same data and capable of servicing requests in a similar way. In each of these instances, we'll have a normal, regular IP address that you can access for management purposes, but we'll have a shared IP address, and that is the Anycast IP address. And that's the one that is being used and is being announced from different locations. And through BGP, you're able to access the one that is closer to you from a topological perspective. We're going to see an image. So what you would have is a client. So you can see that this is a typical or a diagram where you can explain how the technology works. You have 3 servers, 3 instances. They share the same IP address. So whenever the client does a DNS lookup, he's going to find a unique answer. That's the same IP address. However, router 1, its routing table contains 3 potential ways of reaching that IP address. You can imagine, and the idea is that the closest of these 3 instances will be the one on top, the server instance number 1. There's only one router that you need to go through, whereas the second there will be 2 and 3 for the third. So in reality, the way the router sees this is that he thinks that it is the same instance, and there's different ways of reaching to it, whereas in reality, there are different physically located instances. So through the routing table, the client will reach that service instance using router 2. And that will be the basic of using Anycast. So Anycast and DNS has a long history. It is not something new. It's been operating for many, many years at PCH, and some people before PCH, they've been running through the end of the 80s. And the idea of anycasting some root and TLD of the DNS happened back in 1995. So this is something that is not new. The idea is to show that this is not something new. It's something that has been happening for a while. We as PCH, we began operating production Anycast for CCTLDs and in other zones in 1997, and we started with the Anycast production of a root name server in 2002. So this is a little bit of the history. We operate services through V6 since 2000, and that's just an addition to it. So for some of you that you might not know, this is how our Anycast Cloud looks like. We operate this cloud in the autonomous system number 42, and the image on top, apologies, the contrast doesn't look very well, so it looks like half of the world is there and half is not, but on the presentation you'll be able to see it. The map on top displays all of our 150 locations in the 5 continents. We have around 118 nodes, and of those 18, there's 14 global nodes and 4 are high traffic nodes. The rest will be nodes of medium size that will be serving an internet exchange point and the networks that participate at that exchange point locally. These are some of the data of our network. On the bottom, you can see the countries which we provide secondary authority service for them. This is only the CCTLDs. This is about 105. And there are also 2 letters of the root, DNS, droot and eroot, that host their servers within our network. So this is a view of the cloud we've built. So I'm going to get a bit more into detail on how it looks. This is a day in our network. I've pulled up some statistics for you, so we can see, for instance, that, well, as you know, most of the DNS traffic is UDP traffic. There's very little TCP, at least we get very, very little. So this is what you see. In terms of V6 and V4, you can see that there's I would say it's 1/8 of our traffic is V6. I haven't. There's no history on this, and if you would see a history, you would see how this has been increasing, obviously for the past since 2000. But this is a snapshot of I don't know, one day in September, I think the 2nd of September. Another thing that a couple of new graphs are related to the DNS queries and how they're processed in some of the global nodes and on the rest of the nodes. So you can see that a large majority of the queries are answered or are handled by those global nodes. which are generally sitting at the core of the internet, so in locations where most of the large networks meet and exchange traffic. And sometimes this can be problematic because we would love to be able to distribute and to push traffic in more at the edges of the internet, so in exchanges which are much closer to the user, but sometimes we face challenges, as I would explain later, because some of those providers would not peer with us at those exchanges and would rather peer with us at larger exchanges. So the traffic will look as a global node, whereas it could be actually on a smaller node in a smaller city. And by region, if we look at by region, you can see that there's still a lot of work to do. It's related to what I just explained. You can see that a third, well, less than a third of the traffic is distributed through the ARIN region. The RIPE region would be another third, and then we have IPNIC, and between LACNIC and AFRINIC, you can see that very little of the traffic is distributed there, and that means also that well, there's more work to do for us to get more of our nodes and to ensure that some of the networks that are present there, we can peer with them at those locations. Anycast, as I was saying, is a robust and well-proven technology. It works. Recently, a network intelligent company was doing some stats on okay, I've been shown the sign of stop now, so I'll go very quickly. Some considerations, and you have here the you have the slides online. So some considerations when planning for new sites. An invitation from an exchange operator to host a new node. This is something that we very much welcome. So whenever we get an invitation, we're very happy generally to send a node and to start peering at the exchange and to add value to the rest of the members at the exchange. We look at the traffic levels, at the number of participants, and what are the prefixes that are exchanged at the IX. We look at the availability of our transit providers and the relative location of other nodes. So looking at those, you're able to predict, and you're able to, not to predict, but to plan which can be your next move. And as I said, delivering content in some regions can be challenging. Less developed interconnection markets in emerging economy, that makes you having less options or on how you can deliver that traffic. There's some locations or some countries where there's an absence of open and neutral exchanges where you can do public peering, and this is a problem. And what I said, large networks won't be peering at small exchanges, so you end up having the same global nodes. In terms of operations, I would say that depending on the size of the node, we will present all services or a partial set of services. So you can imagine global nodes, there will be larger installations, they're generally 7, 9 rack units. You will present all services there. Smaller installations you see in locations which are more at the edge of the internet will be more compact and will present only a partial set of services. And monitoring, multiple layers of monitoring, proactively detecting, passive monitoring tools, and active monitoring using RIPE Atlas and some of the great tools developed by the RIPE NCC. Thank you very much. If you have questions, please feel free to grab me on the coffee.
Есть вопросы? Thank you.
Do you have any questions? Thank you very much for your presentation. We are beyond the agenda, a bit delayed to have our coffee break, but I believe that the presentations you heard, they're worth it. And now, please enjoy your coffee break, and after that, we will continue.